Hello again. Let's talk about exterior angles of polygons, and in particular, what happens when we have a regular polygon. So to get the ball rolling here, let's do an example which explains what an exterior angle is. Here we have a polygon with n sides. We don't know how many, it's not really important here. We have an interior angle here, 133 degrees. What we're going to do is draw an exterior angle for this interior angle. What we do is, we have a vertex here, okay, of course we have a polygon, we have sides, and we have vertices. This vertex here, I'm going to draw a line here, I'm going to extend one of the sides. You can extend whichever side you like, you have a choice of two. I'm going to extend this side. So this is 180 degrees, a straight angle here. The angle on the outside that is not 180 degrees, that is your exterior angle. Okay, so this angle here is our exterior angle in this case. And to find the value of the exterior angle, it's pretty straightforward here. Here we've got 180 degrees, and on the inside you can see we've got 133 degrees, and the exterior angle added together will also give 180. So the value for the exterior angle is always 180 degrees minus the interior angle. So in this case, 180 degrees minus 133. Okay, because hopefully you can see that the interior angle and the exterior angle are going to be 180 degrees. They will be supplementary. Supplementary, of course, means the two angles add to 180. Okay, and if we do this subtraction, 180 minus 133. 10 minus 7, 10 minus 3 is 7, 7 minus 3 is 4, 1 minus 1 is 0. We get 47 degrees as the value for our exterior angle. Okay, so this angle in here is 47 degrees. Got it? Just keep in mind, instead of that, we also could have drawn this as our exterior angle. Okay, we could have extended it this way. Okay, and we have 180 degrees here, of course. Okay, and instead, that could have been our exterior angle. Alright, so that's why I specifically asked, draw an exterior angle. Because for every interior angle, there are actually two possible exterior angles, and they'll always be the same value. So the interesting thing about exterior angles is it doesn't really get exciting in polygons until we have a regular polygon. So here, let's imagine this is a regular polygon with n sides. We don't know how many sides, it's not important. From the formula, hopefully you remember it, each interior angle is going to be n minus 2 times 180 divided by n. Let's have a look at what each exterior angle must be. So to do that, once again, let's just draw an exterior angle. Okay, we extend one side. Okay, and one of the exterior angles is going to be 180, and it's the other angle is our official exterior angle. This one here. How are we going to find that value? Well, hopefully remember each exterior angle and each interior angle are supplementary. So each exterior angle is 180 degrees minus an interior angle, n minus 2 times 180 degrees, all over n. Let's use our distributive property here, our little distributive rule, minus 180 times n, 180 degrees n, 180 times 2, minus 360, all over n. Let's split these fractions up. To do this, we've got to imagine we've got brackets there, and this is kind of like a minus 1 at the front. So doing that's going to become 180 degrees minus 180 degrees n over n, minus minus becomes a plus 360 degrees over n. These ends will cancel out, leaving us with 180 degrees minus 180 degrees plus 360 degrees all over n. And look what happens. All we are left with is 360 degrees divided by n. Okay, so each exterior angle of any n-sided regular polygon, sorry, that should say regular, is 360 degrees divided by n, the number of sides. So let's take that formula for a test drive. Let's dive into another example here and use that formula. We're going to determine the size of each exterior angle of a regular octagon. So let's write the formula first. For a regular polygon, the size of each exterior angle is going to be 360 degrees divided by the number of sides. Here we have an octagon. How many sides does an octagon have? Hopefully remember, an octagon has 8 sides. Let's put that in. So it's 360 divided by 8. What's 360 divided by 8? 360. 8 going into it. 4 8s are 32. So 4 8s are 32, remainder 4. 8 into 40 goes 5 times. Okay, so it looks like each exterior angle is going to be 45 degrees. Does that make sense? Just to satisfy my curiosity here, a regular octagon, that's one of our standard stop signs, isn't it? Okay, and that would mean if we draw an exterior angle, such as this one here, okay, there's 180, so the exterior angle is the other one, that would be 45 degrees. Yep, that looks good to me. Agreed. And just another interesting thing happens when we have a regular inside of Polygon. Let's have a look at the total sum of the exterior angles. So what's going to happen is the exterior angle sum of a regular inside of Polygon, all we're going to do is multiply each exterior angle by the number of angles, okay, which is going to be 360 degrees, that formula we just did, times n, okay, because n is also the number of exterior angles as well as the number of sides. And what happens here is something very simple. The n's cancel out and we get 360 degrees, no matter how many sides. The total exterior angle sum of any regular inside of Polygon is always going to be 360 degrees. And that's the same as a circle, isn't it? When you go around a circle, it's a 360 degree revolution, isn't it? So it's kind of like starting here, and as you move around, you sweep out an angle, and it's kind of the same as a circle. Once you go all the way around, you've got 360 degrees. I wonder if they're kind of connected. Very interesting. Do you believe that the exterior angle sum of any regular polygon is always going to be 360 degrees? Maybe we can demonstrate it with a couple of instances. What's a basic case for this? A basic n-sided polygon with the angle sum is 360 degrees. What about a regular triangle? 3 sides. That would be an equilateral triangle. Each interior angle is 60 degrees, which means each exterior angle is going to be 120. 3 times 120 is 360 degrees. That agrees. What about a regular quadrilateral? 4 sides. That would be a square. Each interior angle is 90. So each exterior angle is also 90, and there are 4. 4 times 90, 360. That also agrees. So it sure looks like the exterior angle sum of all regular polygons is 360, undeniable. And do you think this is also true if the polygon is not regular? What do you think? It's now your turn to do some work. Please try example 3 and example 4. For example 3, we have another interior angle in an n-sided polygon. We don't know how many sides, it's not important. Draw an exterior angle for this interior angle. Remember, there are 2 possibilities. And what is the value of that exterior angle? In example 4, determine the size of each exterior angle in a regular pentagon. How many sides does a pentagon have? And just to check on the side, draw a regular pentagon. And then draw an exterior angle. Does that angle look like it matches the diagram? As always, thanks for watching. Don't forget to put your answers in the comments section, and I'll see you next time.